Hello and welcome to a quick screencast for Pure Data as part of mus355. Building on things we've done in past years, but also a couple of things we've done last week. So I've got PD open, I'm going to make a new file and I'm going to save it into a folder. I'll call this TT1. We're going to look at tables and arrays today. I'm sure I've mentioned it in the past. And this video will also be useful to some of the composers. So I have a folder here with some objects already made, plus two sound files. One is very much a mono sound file and one is a stereo sound file. So to begin, we're going to think about how to load sound into the computer and then write sound out of the computer in both stereo and mono. So to do that, we need a DAC object. That's put object and DAC. I'm going to use shortcuts now. Please get used to the shortcuts. Control 1, 2 and 3. Control Shift B for bang. Control Shift T for toggle. They're the ones I use all the time. And in order to turn the DAC on from within the program, we use a message box, semicolon, space, PD DSP $1, and $1 allows you to send in a variable within a message box, and this is a way of doing a message that sends directly to a specific place. So I need a toggle box going in here, and if I was going to actually start my audio as soon as you started the program, I would put an object box and a load bang going to a message box with a 1 in it. So this will trigger my audio as soon as I load the patch, and as you can see, DSP is on. And save. So the next step, we need to create some tables, and that is done, or it used to be done, using put array, but now what we do is define the array, define, and a name. So I'm going to call this one my table, confusingly because tables and arrays are very similar. This will be a mono table, but if I want a stereo one, a stereo sound file, I will have my left and I will define my right. And the object to load sounds into tables is the sound filer. It's the default object for working with sound files. So if we have a look at the help file for that, you can see loading mono files, find the file, load it into an array name. Find the file, there's some presets there, there's the file name, load it into a left channel and a right channel. So these are all messages, put message, and read minus resize, because this table, all the tables come up with a default of 99 points. And if that's 99 samples, that's going to be useless. So we need to resize the array to the size of the sound file we load. Watersync.wav my table. And that goes into the sound filer. Now I'm going to do the same thing for my left and right. So this will be Mendel4.wav into my left and my right. Now if I save this and click on those two, there's no errors here. There's my WaterSync. Sound file size 220,570 samples. And my left, my right, you can see it's loaded the left channel in here and the right channel into my right. And they're clearly different, and they'll sound different. In fact, they'll sound so different, they'll sound awful. The next thing we need to do, and you will need to know this, is you'll need to get hold of this number. And this number comes out of the sound filer. So if I put a number box here, and I make this number box quite big, check properties, and instead of it being 5 units big, I make it 10 units big. when I open that, there is the size of that sound file. You know the sample rate. The sample rate is 44,100 samples a second. So from that, you should be able to work out the duration of the sound file. Homework. The hard thing then is to store that as a number related to that sound file, because as you can see, when I do this, that's a different number. And the reason why you'd want to know the duration of a sound file is because you'll want to play the whole of the sound file or parts of the sound file. So I wouldn't want to play a number further than that sample. So you do need to know the exact size of your sample. So let's play it. The simplest way to play from a table is tab play. Space, notice these have all got tildes on when they're audio, and space, name of array, not name of sound file. So my table. And I'll just go with some amplitude control now. I'll put a multiply box here, send it to there. And here's a very cheap trick for doing volume on and off. You know what on and off is. It's a toggle box. So toggle goes there. And a bang to tab play would play the whole sound file. We did this in past sessions using drum samples for making a drum sequencer. So I'll turn the volume on. And that plays my sound, and from that you can get an idea of the duration. Remember, you get a bang out of here at the end of the sound file, which is useful for creating loops. Let's have a look at the stereo sound file now. Tab play my left, tab play my right. Bang on both of them. I won't worry about, shall I worry about the volume? Yes, I will. Duplicate that, duplicate that. I only need one volume control for both of them. So put that there, make it look neat. That goes out of there, that goes out of there, that goes to there, and that goes to there. Turn that one off, turn that one on. Check that these are there. They are. Play it. So that's been butchered to a very odd stereo in Audition, just so that I can prove to you it's stereo. Right. Tab play is useful when your sound files are fixed and short, but you may want to change the pitch of a sound file. So to do that, we use tab read 4 tilde my table. This now needs a signal which tells PD what sample to play. And in order to do that, we need to obviously have something that goes from 0 to 1 as a bare minimum. So that's a phasor. And the phasor will have to run at a frequency. So if I multiply that phasor output by 44,100 and read my table, give myself a little bit of volume control and on off, what am I expected to hear? If I select this to 1, over 1 second this phasor will go to 0 to 1. It'll in fact go from 0 to 44,100, and it'll read 44,100 samples at a sample rate of 44,100, so you'll get 1 second of sound at the right pitch. Okay, that loop's driving me nuts. Slow it down. Speed it up. Oh, and reverse it. So you can read these backwards. That's interesting. That's quite cool. A bonus. So I'll make this a little bigger. And we could do the same with the stereo sound file as well. We could read specific parts of this sound file. If I duplicate the whole of that, the thing about the phaser is it goes from 0 to 1 and then back again at a certain speed, and it doesn't stop. We could be very specific and use the vline object to say how far we want to go from where to where at a specific, over a specific duration. Now the vline object is complex, but once you understand it, it's very useful. Its help file is here. Generates linear ramps whose levels and timing are determined by messages. So message box consists of a target value, a time interval, and an initial delay. So it's useful for making ADSR, attack decay, sustained release envelopes. Put a message box into it, and I always start with 0, 0, 0. At time 0, let's be at 0, and let's go there straight away. And I want to go to 44,100 samples in 1 second. Now, that's not 44,100. The seconds duration is in milliseconds. So 1 second will be 1,000 seconds. And I want to do that instantaneously. So there should be no sound until I press this. Now with messages, you could put a bang and bang it, but you can actually just click on a message. So let's say I wanted to go 88,200. So I'm still doing it in 1 second. So we're actually going twice as fast, octave up, but we're covering 2 seconds of samples. So that's a way of doing very specific trajectories through sound. I think from a point of view of building up a sampler, you may want to use a phaser. That's the end of part 1.